It's time for Pure Performance.
Get your stopwatches ready. It's time for Pure Performance with Andi Grabner and Brian Wilson. Hello, everybody, and welcome to another episode of Pure Performance. My name is Brian Wilson, and as always, I have with me my amazing, wonderful co-host, Andi Grabner. How are you doing today, Andi?
Very good. It feels, it seems like we haven't done this in a while, because what the listeners don't know is that you just needed a second attempt for the introduction. Which
right, it's been so long.
It's been so long, yeah. And which also tells me that you are not an AI, because an AI would have not made that mistake.
Right. But before we go to AI, because I am excited about today's show, I have to let you know I'm disappointed in you. So any eagle-eyed listeners who look at the thumbnails might notice I have new colors on my microphone. And I've had this for a few weeks now, and nobody that I interact with at work has noticed it. And I figured, well, Andi will notice. He sees me on the mic all the time. He'll notice it, and you didn't. So I got some nice little overlay things for my mic. It looks like some lemon lime sherbet or something, but I figured I'd get something from you, Andi, but you let me down once again.
Well, I'm really sorry for that, but let's folks.
But what won't let me down?
Yeah, our guests.
Good code from AI.
Good code from AI, exactly. And for this is kind of like, for me, it's amazing. 6.5 years has it been since we recorded the first episode with our guest. Back then, the session was called Code as a Crime Scene, Diving into Code Forensics, Hotspot and Risk Analysis with Adam Tornhill. Adam, thank you so much for being back on the show 6.5 years later. I'm pretty sure a lot of things have happened. We will talk about this. But first of all, for everybody out there, who is Adam Tornhill?
Well, first of all, thank you very much for having me back on the show. So I'm Adam Tornhill. I'm a programmer based in Sweden. Been doing software development for a long time. I'm still enjoying it, perhaps more than ever. I'm also an author, and the best known book is probably Your Code as a Crime Scene. That came out in a second edition a couple of years ago.
Wow.
I'm also the founder of CodeScene, where I work a lot with code analysis and automating the stuff from Your Code as a Crime Scene. So that's like my life. Yeah. And when I'm not coding, I'm super interested in retro computing and music and history in general. That's pretty much me.
Now you need to fill me in retro computing. That means like you have old hardware running around, like laying around and playing with it, or what?
You have a Sinclair?
No, not Sinclair. That's too modern. I go to 1970s, like Atari 2600, Intellivision, that kind of stuff. I really love to play around with these old machines.
Wow. So is this, I mean, unfortunately, I'm completely not into this type of history in IT. My first computer was a Commodore Amiga 500 from the 80s. I'm just curious, how do you still get spare parts on these things? Or obviously you have to repair everything, or is there still an industry around this? Can you still buy these things?
You can pretty much still buy the original hardware if you want to. I'm cheating a lot. I'm using a lot of emulators because I'm mostly interested in the software.
Okay, cool. Awesome. Well, I learned something new about you. I did not know that. Hey, Adam, I remember the reason why we had the first podcast is because we met each other at a conference. And if I don't remember, but it was probably in a conference in Europe, a conference related to code quality, to software engineering quality, because that's kind of my background, your background, Brian's background. And for those that didn't yet listen to the Code as a Crime Scene, or haven't read your book, or haven't read any of your material on that, can you quickly give a quick overview of Code as a Crime Scene and what you have done back then that kind of now also resulted in a second edition of your book?
Yeah, I'm going to make an attempt.
Yeah.
So Your Code as a Crime Scene is very much about the idea that the bottleneck in programming is not writing code, it's understanding existing code. That's where we spend most of our time. And your code as a crime scene is a set of techniques that help you pick up a potentially large system, large code base, and very quickly identify where are the main bottlenecks. And those bottlenecks, I call them hotspots because they're development hotspots. So these are overly complicated pieces of code that we need to work with often. So what I do is I call this behavioral code analysis, is that I combine code quality information with behavioral data from our version control history. And that enables a bunch of interesting use cases. And the book, Your Code is Crime Scene, was written based on the patterns and techniques I had developed during my years as a consultant. And after writing the first edition, which was in, 2014, after writing that book, that's the reason I founded CodeScene, because I wanted these techniques to become accessible and mainstream. So there had to be good tooling behind it. So that's pretty much it.
Mm-hmm. Now, for me, this sounds, and I'm going a little bit into a direction because I'm interested in this now. I want to understand, if you think about, you said understanding existing code is a very hard thing. And it feels, what I know about the topic of today, AI coding tools, this is actually a big strength of, it feels like, AI coding tools. Understanding existing code, or at least trying to understand existing code bases and then giving suggestions on how to improve it. Based on your work, on your research, is this true? Can AI understand especially very old code bases that have been lingering around? Sometimes we call it legacy code bases, because I'm sure you have a lot of experience in this as well. Or is there somewhere a line where you say AI is not as good as we hope because there's not enough material, it has not been trained enough? Just curious to hear from you.
Yeah, sure. And I'm going to try to keep the explanation brief. Yeah. But basically, if I take a step back and look at us human developers writing code quality has always been important, whether we have acknowledged it or not. And there is previous research. Me and my team did a piece of research that was called Code Red, the business impact of code quality, a couple of years ago. Mm-hmm. And what we showed there was that code quality has a massive impact on development time and defects. And this is, of course, unsurprising to anyone that has worked on large-scale systems. But what we found now was that code quality is even more important to an AI than to a human. So we have done a new piece of research that is called Code for Machines, Not Just Humans, where we study the actual performance of an AI as a function of code health, of code quality.
Wow. So many new questions. So, because one of the things that and obviously I only know a fraction of what you know on that topic. So excuse me if I ask stupid questions. But obviously the machines, the AIs, the models are trained based on available data out there. Do we have any idea on how much of that code that was used to train is actually high quality code versus code that is not the quality that we want and therefore resulting actually in bad quality again? Do we have any idea? Or?
Yeah, I can give you a pretty good idea on that, because we've been benchmarking a lot of large-scale code bases over the years. So the metric we use to assess code quality, we call it code health. So it's an actual metric. It's a composite metric based on 25 code smells that we try to identify in the code, mostly concerning structure and design. And what we find is that the maximum is 10, of course. That's like perfectly readable code. And then it goes all the way down to 1, which is code that you never, ever want to see. And the average in the industry is 5.15. So wow. Roughly in the middle of that scale. And what we consistently find in our research is that if you want to keep AI-induced defects low, if you want to prevent AI bugs, then you need to have a code of at least 9.5 in order to be able to fully accelerate with agentic AI. So I would claim that there is definitely a massive disconnect between what the typical enterprise code base looks like versus where an AI can do a really, really good job.
Now, do you know if the big companies that are currently offering coding agents, whether it's an Anthropic, whether it's OpenAI, whoever's. Do you know what type of material that they use? Have they ever reached out to you? Because I think that would be very important, right? I mean, these models, they need to be trained on something that has a 9.5, as you said.
Yeah, that's a very good point, because I think that's one of the missing pieces for these AI coding tools. That what we also find in our research, which is very interesting, is that once you start to give the AI additional context, information on why isn't this code a perfect 10, what's missing, as soon as they get this objective measure, they can form a goal and they can build a plan, and they do a really, really good job at remediating potential code health problems and issues they introduced itself. So this contextual information, it's really, really key. So yes, I think that would be a really, really interesting use case to get closer to these AI coding tools and agents.
Mm-hmm.
I think it's interesting to point out, just for, the average person, right, who thinks, AI is intelligent. I keep making the case that it's not. It just does what it's, trained on and all. But to your point, right, it's only going to code as good as the code it learns from. It can't analyze the code to say this is good code or bad, unless you, as you said, give it that further learning, those further prompts to teach it that this is why this is bad, don't make these mistakes. But again, I have this argument with my wife and kid all the time, like, no, it's not intelligence, it's just doing what it learned, If it were to turn around on its own and say this code is bad, to me, that's where the intelligence is. But really, it's really good to hear that, like, if you can prompt it to say, this is why it's bad, this is what's bad, that it can pick up on that and then learn. I mean, it makes sense it can do that, but, I think these are probably things common people who are using AI for coding are either not aware of or aren't thinking much of yet, which is why, again, looking at the notes for the show, I think this is a lot of fascinating topics. So I'm going to shut up so we can continue getting onto them, because I think there's a lot of great stuff for you to share with the audience today.
Adam, obviously you're looking at your own personal history. I just like you, Brian and I, we've started in a time where there was no AI coding available, so we obviously had to learn the craft from the bottom up. I think I consider myself very fortunate that I learned software engineering already in high school, and then kind of took it from there and learned more and more. And obviously for you, the same thing. We've been around for quite a while. Since when have you been kind of exposed to AI coding tools and maybe some of the lessons learned or some of the things you've seen from somebody like you and I and Brian, where we have a big background in software engineering? How do those people use maybe AI tools differently than somebody that now sees an opportunity to say, hey, we can now finally bring our dreams to life because we can now use all these coding tools, even though there's no real background in software engineering. Do you have any insights here?
Yeah, I mean, I can start at a personal level. So I have to say I was quite an early adopter of AI coding tools, because I saw some promise in AI to solve a really, really hard problem I've been struggling with for years. So with the code as a crime scene techniques and with the CodeScene, we have always been quite good at identifying bad code that is hurting the business. But that's really only the first part of the problem. The next part is, of course, that now someone needs to act upon this. And that means improving and refactoring the code. And refactoring really is an expert skill. I mean, it's a learnable skill, but at least for me, it took like 10 years before I got any good at it. So it's a really, really hard skill. And this is where I had a big hope for AI, because I thought if we, refocus AI instead of, focusing AI on generating more code faster, what if we used AI to uplift existing code and take away this bottleneck? So we did some early research on that in 2024, published a paper more than 2 years ago using AI for refactoring. Back then, it wasn't really a viable option, but I've been following along closely. And starting 5 or 6 months ago, I went over and started to write all my code using coding agents. So after almost 40 years of coding and studying programming, I haven't written a single line of code in months now, manually. So this was quite a big shift for me. However, what I find is also, and this might be my experience, but what I find is that I could never have adopted agentic AI the way I do if I didn't have all these decades of experience behind me. Because those decades kind of taught me the high-level patterns. How do I reason about architecture and design? How do I modularize stuff? And it also taught me to quickly read a lot of code. Because I find that even if AI speeds up the coding process, you still have, the major bottleneck becomes validating whatever the AI built. So there I'm really, really grateful that I've been learning all the good engineering and delivery skills.
I just had, just before this recording, I had a solo recording because it was a little too early for Brian. And again, sorry, Brian, that you couldn't be part of that previous session with Wolfgang and Benedict. But we also talked about what is a good, not capability, but what is a good attribute for a good software or AI engineer to have. And I then came up with the analogy, and I'm not sure if it's the right word, but I remember we talked about T-shape people, T-shape engineers, meaning you go broad, but you don't have to go deep on everything. Broad meaning you fully understand, ideally, in software engineering, everything it takes to understand the business problem, crafting the requirements, starting to code, writing the proper tests, knowing how to deploy, how to observe, how to secure and operate, right? Ideally, you know everything. And then you don't need to go deep in every single aspect, because you may have your human colleagues or now your AI agents that do a much better job when talking with you, when prompting with you, to then do a certain task. But you still need somebody that understands everything end to end. It actually makes sense. So,
Andy, sorry, continue.
Yeah, and this is why I think I wanted to ask you, Adam. I think we have the benefit of having been in the industry for so long that we have seen good and bad architectures, good and bad examples of software that solves or doesn't solve a certain problem. And we have a good understanding of an end-to-end software development lifecycle. But we don't need to be a deep expert in the latest runtime of Java, in the latest cloud native technology, in the latest observability trend, because this is where we can then use our agents. And I think just wanted to confirm a little bit if this makes sense.
Yeah, to me, it makes a lot of sense, because that's what I'm finding, that to me, being fully agentic in my coding, it doesn't fundamentally change my experience. It feels very much like it always did. The big difference is that I can take on larger and larger iterations, right? Mm-hmm. So the feeling is still very much there. And I think that's the big benefit of AI, that it kind of, I can start to thinking bigger patterns, bigger building blocks. Mm-hmm. So for me, it's a little bit similar to the feeling, when I'm starting out as a junior, just learning to code, you might focus a lot on syntax, like how do I write the for loop, right? Mm-hmm. And, becoming more senior, you quickly start to thinking like algorithms or maybe complete patterns. And to me, AI is a very natural evolution of that. But I agree, everything that happens, coding is really just a small part of software development. Mm-hmm. And we need to maybe not be experts, but at least have a good understanding of what makes a robust and strong delivery pipeline. How do I guarantee that the code is secure, right? That I can continue to develop it and change it a year from now. And I don't think there are any shortcuts. I think we need to live through this, right? Mm-hmm. Mm-hmm. Live with a system for an extended period of time to learn those skills.
It's interesting, Andy. When we were talking with Jeff Blankenberg a little while back, he had the same concept, right, of still have to check the code, right? But it sounds like we're going to be more development designers, or designers instead of the actual, like if you think about even like in fashion or architecture, right? And I might be getting some of this analogy a little bit wrong because I don't know what goes deep into it, right? But if you're going to design an outfit, right, you may or may not, you're probably not going to be crafting or putting that outfit together, or at least beyond the prototype, but you have to know what's possible. You have to know what it's going to, if you're going to have some kind of fancy structure going on in it, you need to know, can that be done? How would it get done? But you're not going to be doing the actual construction of it, right? And in this case, it's going to be the AI that's going to be doing the code. But as you, Adam, said in your notes and probably already on the show, as Jeff has said, and I'm sure as Wolfgang and the others on their previous recording, you still have to go back and check and verify what AI is delivering to you, right? And to me, that's what solves the problem of the next problem that comes up, right? If we talk about the newer generation of what I'll call designers right now, if they don't have this background experience, how do they know what's going on in that? If they're not spending years in the trenches writing the code and all that, right? They're not getting that experience that the previous generation is built off of. But I think that's taken care of, as Jeff mentioned, is like if you give the juniors the code to review, to look to make sure AI is doing the right thing, that's when they're then learning what this all does, right? So at least in my opinion, the way to continue the cycle of having newer people coming up and understanding the fundamentals is for them to spend the time in the trenches doing the review of what AI did, right? And as they're understanding what that code is doing, I think that's going to then help them understand the bigger picture so they can be a good designer later on.
Mm.
Am I way off on that, Adam, in your opinion? Or like, I guess the big question is like, how do we continue to have newer people coming up, understanding the fundamentals, so that they can make sure AI is delivering it in the way that they want it to be delivered, if they haven't gone through that process like we all have?
Yeah, no, it's a super interesting topic, and I really hope that you're correct. Personally, I'm a bit worried for the future of our field, because I think with AI, it becomes so easy to shortcut our learning cycles, our feedback cycles. And as you might know, I have a background in psychology, so I have my second degree in psychology, so I'm super interested in how we learn and solve problems. And I do know that true learning comes with effort. It has to be effortful. We have to struggle a bit in order to internalize and truly learn. And I think the temptation is just going to be there to kind of shortcut that learning experience. So I think this is a big challenge for us in the industry to solve, to kind of grow the next generation of software engineers, because we're going to need them. I'm very convinced.
Mm. In the previous podcast that we recorded, there was a nice statement and kind of concluding the new role of software engineering. Maybe I think it was Wolfgang. He said, in the end, nobody will judge you on how you code it, but you will be judged on the value that you provide. Right? And I think now we're opening up this field of creating software to solve a certain problem, to provide value to many more people. And in the end, nobody asks, was it implemented in Java, .NET, or C#? But I think what will matter, however, for everybody that is using it and that needs to operate it, obviously with the qualitative aspect, whether it's secure, whether it has the right quality, it's resilient, and all these things. But I like the statement, right? We will be measured against the value that we provide and not the individual lines of codes that were created. I would like to ask you a question now on this it has to hurt in order to learn, because I remember when I started my software engineering career, I was trained software engineer from high school, but in my first job, I was put into the QA department for the first 6 months to really learn the craft of good software quality, or learn it from the other side, meaning testing. That means I was a tester and had to test the product that later on I had to develop, which was really great. I basically gave feedback also to the engineers, what worked, what didn't work, and so on. So this helped me a lot to appreciate quality. Now I wonder, and do you see this? If I have coding agents, do coding agents have a sparring partner or a counterpart agent that is the quality agent that validates what the coding agent is doing, giving proactive feedback so that the coding agent can learn with all the mistakes? Basically mimicking what we are doing in real life, right? Where we had our different roles for coding, for quality, and they were obviously hopefully exchanging information, learning from mistakes. Is this happening already? Do we see these different agents and also the coding agent and a quality agent kind of collaborating?
So it's kind of interesting because I had a very similar journey, almost by coincidence. I was, of course, also trained as a developer, but my first job was actually QA. Mm-hmm. And I think it's very useful because in QA you get that critical thinking naturally. You're so used that software breaks, so you kind of learn what to look out for. And I think I learned lessons that are still serving me well to this day. So what I find with AI, interesting enough, is that yes, I do meet people. I mean, we have customers that implement dedicated agents to verify quality. I personally don't think we are quite there yet, because what I find during my agentic coding sessions is that the worst code is always the test code. And I simply think that that reflects the training data for the LLMs. Because, let's face it, as a software community, we haven't really done a stellar job at developing solid test automation code, right? That's always where the worst technical debt is, and we might not even know what patterns do we need to develop good test code. So that's where I find that I have to coach my agents the most on the test code. That's where I find most of my review comments, and that's where I have most of the feedback. So I think this is a massive, massive room for improvement over the next few months.
Mm-hmm. But then I ask you, coming back to both of our histories, right? We are both trained software engineers, but we had to start in quality. If we then now adapt this in AI, shouldn't we force the coding agent to do the review for a while to learn about good and bad software quality? Would this work, or is this just completely stupid thinking from my side?
Completely stupid.
No, I'm definitely convinced that it would work. And parts of the quality problems, like the internal quality, that I think is already a solved problem. So that's what we do in order to make agentic coding fly. We took all our code health knowledge and we encoded it in our code health MCP. Mm-hmm. So that one we put into our agents, and that works really, really well because I constantly see how the agent checks the code health, gets feedback, self-corrects, and stays on track. So that works really, really well. And also see a lot of promise in, I complained earlier that test code isn't of good enough quality. It often misses edge cases, tend to duplicate a lot of stuff, which makes it really hard to verify that the right tests have been written. But what I found is that once you manage to establish good patterns, then the AI is also pretty good at mimicking those patterns. So that's where I think there is some hope to make even more progress in that area.
Mm-hmm. So you mentioned the MCP. That's interesting. So that means that MCP gives... So yeah, I assume you have your agent instructions that basically say, after you code and you build, then ask the MCP to validate your code smell or your code health, and then based on that, make adjustments, right? So that's kind of like the closest feedback loop that you actually have here.
Yeah, it's a very, very tight inner developer loop. And the best thing is that you as a human, you don't really have to care. You just have to ensure that the AI knows that MCP is there, that the tools are there. Mm-hmm. And then the AI will call out and do the code health review and automatically correct. And that saves you a lot of time because once you get to like a human review, if you do that, then the code is already healthy, right? Which cuts code review times in half on average. Yeah, so it is cool. A big saving. The other big use case is, of course, for refactoring and uplift, because there is a lot of research coming out now on refactoring and AI. And what we see in that research is that an AI actually does more refactoring than human developers. However, these AI refactorings, they tend to be very shallow, simple stuff like rename variable, right? That doesn't really move the needle on code quality. So once you get this more structural feedback in, then the AI will take that in and do more impactful refactorings, which I think is really, really important.
Just a thought on the MCP server again, because and the feedback to the code quality. We also try to educate our users on doing the same thing with observability. So if you're coding, right, and you're making changes to your instrumentation, you're creating new features that are creating new logs, then you immediately can get feedback after the deployment. Do the logs meet our criteria, right? Do they have all the proper metadata on it? We have not introduced anything where we are logging, let's say, PII data, so personal identifiable information. And that's also closed loop that I always say, this is information. We need to have closed loop back to the human and the AI, because more and more code obviously is created by the AI. So we need to make sure that these feedback loops not only go back to the human, but also to the AI. Yeah. I have a very strange thought now. So we are talking about software languages that we grew up with, right? I mean, all the software languages we're currently dealing with, we are training AIs on the languages that humans have created for humans to create software. Do we think we are going to see a new world where AIs create their own languages to make AIs more efficient in coding? Because why do we constrain ourselves and teaching AIs on languages that we as humans came up with? Is there any trend going in that direction?
Yeah, that's an interesting fact. So what I know from research is that programming language matters. It matters to an AI. So there are like some general trends, like if you have a statically typed language, then there's a bit more context, a bit more constraints, and the LLMs tend to perform a bit better. And then there are other things where a language, take C++ as a good example. So LLM tends to perform quite poorly on C++, simply because C++ is not one language. It's like a multi-paradigm language where C++ code can look basically any way you want. It's a really, really complex language without any clear established patterns. I'm obviously overgeneralizing now. All C++ developers will be angry at me, but that's the way it is. So the thing is that the language really, really matters. And to me, it means it's would be very, very natural to start to develop AI-friendly languages that are simply a bit more constrained, right? And have the right type of verbosity. And perhaps I think the constraints are really key, that there are certain things that you maybe shouldn't allow in that language that can take away some common problems and common bottlenecks. So I think there is an opportunity here. I do think that the language will still have to be human-friendly too, because for the foreseeable future, I really see a hybrid model where you always want a fail-safe, where you want the human to be able to go in, correct or validate, right? So it's not something I see in the short term, but I would definitely think that's where we're going.
Based on all of your research and the analysis of all of these large code bases, do you see a preference of language that is used by AIs or by developers that are using AI generators or like AI coding tools? Is there like a shift towards certain languages and certain runtimes?
I think it's still, I definitely can guess what the trend is. I think it's still quite early stage. So that's also the thing. It's so easy to get carried away. At least for me, I think that, the whole world is agentic. But when you look at these large enterprises, they're really just at the very early stages of exploring AI in coding. So I think the big shift is yet to happen. But what I do see is that the teams that seem to be really, really successful, they typically use languages like Golang. Rust seems to be super popular. And our team internally, we do a lot of Python, which is interesting because it's dynamically typed, but there's so much Python out there. And the language has a lot of good stuff going for it that seems to serve it well with LLMs.
So, meaning with Python, there's a lot of training material out there, and that's why the models are so well trained.
Yeah, and Python also. I mean, if you compare it to, say, C++ that I mentioned earlier, Python has had like the opposite philosophy, right? That there should be one obvious way of doing things, right? And that, I think, has served it well, because that's reflected in its training data to some extent.
You know, I've been wondering during this conversation, me as an outsider, right? I'm not doing development at this point. Talk about AI in the podcast and with colleagues, and hear some stories of how people use it. From where I stand, before talking to people like you and Jeff and all that, there was this idea of, we just tell the AI what we want. It gives us some code back. Maybe we look at it, maybe not, right? But what's coming out in these conversations is that there is much more depth to it, right? Much more intervention required, much more review required. What is your take or understanding from what you've seen on the awareness of developers using AI to code of these additional steps that are required to get good and reliable code versus let me just get it quick and dirty, AI slop style, throw it in there and I'm done, right? Is the community that's adopting it at large aware of the level of effort that should be going into using AI, as opposed to let me just toss it there and take what comes back and pop it in, as sort of extremes?
Yeah, I think in my experience is that it's very much a mixed bag. And there are a couple of things happening right now that I've never seen during my 30 years in software. And one of them is that AI coding, after all, these are developer tools. It's the first time ever I see a developer tool being pushed from the very top. We talk about like boards and owners of company that are pushing a developer tool at an organization, which is really, really interesting. And of course, that push comes with a massive expectation that, yes, we're going to be, 55% faster or whatever we think. And I think this hype is it's really, really dangerous, because AI to me is so promising. We're seeing very real benefits in our own development. Yes, we are faster and our quality is better. We have that measurable. But the thing is that it won't happen on its own. Succeeding with AI, as we've talked about, requires more discipline than doing things the old school way, simply because everything moves so much faster and the impact is so much larger. So I think a lot of organizations aren't super well prepared to deal with this. And the big risk is, of course, that, we tried AI, it didn't work, and you throw it out and you lose speed and you lose time.
So there needs to be that awareness of, almost like, kind of going back. I look at this point in computing history as somewhat parallel to cloud migration, right? Where people, we're just going to toss their stuff in the cloud, or I'm going to turn it into microservices. And there was this idea, like, you need to know what you're doing before you do that. You need to know how to break down these microservices. You need to know if it makes sense to move this to the cloud, right? And so many early cloud efforts failed because there wasn't that awareness of how to properly do that, which, again, another parallel. If you just say, we're going to use AI and it's going to be magic, it probably won't be, right? There are, we'll probably see the rise of, AI practitioners going around. Sounds like a great opportunity, right? Go around and help educate people on, if you want to be successful in moving to AI, these are the considerations. And, I know you mentioned something about the, in the notes, and we spoke about it earlier, like the quality of the starting code base that the AI is working with. And understanding that. So there's a lot to consider with that move.
And the thing is, you can actually pull a lot of that risk forward. So one thing we do with a lot of our customers is that we measure the code health in their code base. We visualize that. And what's so interesting is that inside the same system, inside the same code base, you can be in very different states of AI readiness, because you can have components that are perfectly healthy. So those are the parts we can start to adopt AI. That's where I would do my AI pilots if I was in an adoption phase. And then you have other parts of the code that are simply very, very far removed from being AI friendly. So there I would instead, target on uplift, focus on improving, strengthened with tests around it, that kind of stuff. So having this situation awareness, I think, is a necessity. And I like the parallel you had with microservices, because I do remember that like 10 years ago, everyone had a transformation project going to microservices.
Right.
These days, people are having another transformation project going back to modular monoliths. And I think the difference with AI is that it speeds up the whole timeline. So a microservice transition today is something that you can do within a week, right? It moves so quickly. So making the wrong decisions there and continuing to build on that can have, it amplifies the consequences.
You know, this also brings up another thought that just occurred during this bit of the conversation. You know, we found that when moving to microservices or moving to different cloud technologies, whether you're going to Kubernetes, Lambda, or you're just going to lift and shift, the best approach was to have a predefined goal. Like, what is it that you're trying to accomplish? Do we feel that when moving to AI, there should be more of a goal than to move to AI? Are there more specific goals that people should be saying, we're going to move to AI with the expectation that this is our outcome? If we set that expectation, we can have a better transformation to that. And if so, what are some of those goals that might be starting places?
Yeah, that to me is really key. And I've been asking myself that question too. If it's so hard to succeed with AI, why bother? And I mean, for me, I'm a startup founder. So for me, AI is all about being able to do more faster. So I would be very interested in measuring things like throughput. And I would also like to measure quality, like the external quality, right? And ideally, what I'm expecting from AI is that not only are we going to be able to speed up our roadmap execution, we're also going to maintain or ideally improve quality, right? Which means fewer production defects. So this is the type of stuff I'm measuring. And I think that's really, really important. And I think that that's where I'm so skeptical about measuring things like, lines of code generated by AI, because lines of code doesn't have any intrinsic value whatsoever, right? It's all about outcomes. So that's what I would highly recommend to focus on.
That's a great advice, yeah. Because in the end, as you said, it doesn't matter how what you did to get to that result. The real thing is, what is the impact that you have with this, and that's kind of the value. Coming back to that statement from the previous podcast, show the value, and nobody asks about how you got there. I would like, because time is flying. I know we have a lot of cool blog posts from you folks. If you're listening in and if you want to learn more from Adam, from CodeScene, everything that Adam and team has done, there's a couple of links in the description of the podcast. I'm just I have two more questions. I think the first one you already kind of answered a little bit, but you talked about you're working with a lot of enterprise customers and they're still a little bit hesitant or they're getting ready. What are some of the things you can give as a piece of advice for enterprises to get readier, to get their codebase AI ready? What are some of the practical tips that you can tell them?
So I always view it as a 3-step process. So the first would be to, I'm focusing mostly on code quality. So I'm going to assume that there's an equally strong focus on things like build pipelines and delivery pipelines. But from a code quality perspective, what I always recommend is number one is create situational awareness, measure code health, see which parts of the code are good and where it's lacking, and then map that to your roadmap so you see, okay, where is the real friction? And of course, techniques like a hotspot analysis really helps to point out where are the potential bottlenecks when adopting AI. Then for the parts that are good, what I always recommend, and this might be the most important one, is that's where you can start to accelerate, perhaps even going agentic. But you do need safeguards. So that's where we recommend that, pull in the code health MCP server, integrate that, and have the AI to self-correct to make sure that it doesn't spiral out of control. And for the parts that aren't AI friendly, but are critical for your company, for your roadmap, that's we need to invest into an uplift. An interesting thing is that an AI can help that uplift, right? So just because the code isn't AI friendly doesn't mean you can't use AI. What differs is the level of agency you can give. So the worse the code health, the more you, as a human developer, needs to be involved and establish patterns and guide and drive the AI. But I've seen that work really, really well, but it obviously requires a lot of discipline. But the payoffs are huge.
Mm-hmm. Awesome. I love the the term AI readiness and getting it AI ready. So focus on code health, accelerate where you're good in, but use guardrails, invest in an uplift where you're not too good in, but it is business critical. I have one last question that I also asked the previous two guests that we had. Or let's say it's a situation that I've observed and I want to get your opinion on. What I've observed within our own organization, within our customer base, also with my friends who started coding, web coding, all of a sudden, everybody solves the same problem their way because now they can, right? The same tool or the same problem is solved with 5 different tools. The same problem is solved with 10 different apps. The same problems is solved with 20 new websites that do the same thing. So while this is great to experiment, to explore, to understand this technology, I have a fear that within an organization, you end up with a lot of code that needs to be maintained, that might be running business critical processes, but that is duplicated because it solves the same problem. So it's overhead. I also see this from an open source perspective, right? I know a lot of open source projects grew really strong, not because the same problem was solved 100 times and 100 individuals were coding, but because these 100 people came together and together built something that solved a bigger global problem. So I'm just wondering, A, if you see this as well as a trend and whether you see this as a good thing, a bad thing. What is your perspective on that? That would just be interesting for me.
So yes, I think it's definitely a trend. And because the barrier to create something is simply so low now, right? It's so fast. And in general, I think it's dangerous. And I think we lack the type of governance because we aren't prepared for this speed yet. But I think we need to have some governance there. And the reason for that is because creating code has always been relatively cheap. I mean, look at any software project, any software product, and 95% of the costs are after the first version is released, right? And that's not going to change with AI. Even if we no longer count human hours, in the best case scenario, maybe we just count tokens, it still means that 95% of your token consumption is after the first version is built. So why you have these duplicates, right? Where you always have the risk of introducing security vulnerabilities, having outdated business processes. I think it's really, really dangerous. And it all comes back to, the increased importance we need to put on software engineering and software architecture. I think it's going to be more important than ever, and maybe it already is. Mm-hmm. So I'm not sure if that's an answer. I know I answered something at least.
No, it's a great, perfect answer. I love it that you brought up the very good point, right? It's very cheap to create the first version of something, but it's as expensive as it is in traditional software engineering to get it from the first version to something that sustains the lifetime of this thing, to create business value, because you have to maintain it, operate it, fixing bugs. I think that's awesome, yeah. Thank you so much. Yeah. Brian.
Yes.
Yes.
It's the end.
It's the end. But hopefully,
oh, no.
It's the end of the software engineering as we know it.
But it is as we know it. Doesn't mean it's the end of it, but as we know it.
As we know it, exactly.
It feels like everyone's becoming first-time parents by trying to raise these AI coders. But the difference is there's nobody who did it before us. For us, if we have a kid, it's like, we look at our parents or other people, and you have this whole history of it. It's like, we're raising this new AI child to code, but it's never been done before. So we have to figure it out. It's going to be interesting. I don't know if I'll be alive, but it'll be interesting in the future when people look back to the beginnings of this, and what the perspective will be in what was going on at this time. But I think, if we take advice from, people like Adam and others we've talked to who are really looking at this from a pragmatic point of view to do it correctly, or as correctly as we know at this point to do it, and to do it with care. Hopefully there'll be some really good reflections on. But yeah, this set of people over here was really thinking the right way and got kicked off. Because it's way too tempting, I think, to just say, hey, do this for me, and I'm going to move on. Right. So hopefully we get the word out there to not, yes, it's going to help you. Yes, it's going to save you time, but don't be careless with it.
Yeah, I think the important takeaway for me is, it's just that we're getting faster, but we must not forget the guiding principles of software engineering, which is good automation, good quality checks, close feedback loops, whether it's to the human or to the AI. And the AI will help us obviously get faster, but we need to have these guardrails. Adam, thank you so much. Did we forget anything? Any final words? Any advice for anybody out there before we close this session?
Yeah, well, thanks a lot for having me. And my advice is, with AI, doing it right will give you a speed up, but it requires more quality, more skills, more feedback loops, right? It's arguably harder than doing things manual way. So be prepared for that and do the right thing.
And deliver value. Hey, I think there's an interesting future topic in here potentially, Adam. I'll throw this out at you. Or as you're going through more of this, I know you mentioned the profile, not the profiling, but the hotspots, which again ties back to the code as a crime scene. Very nice connection there too. But I think it'd be interesting to see, come back and have you on in the future to take a look at what are some of the patterns we're seeing in that not ready for AI code. And what those shifts and changes have to be to make it ready for AI. So as you gather more or see more on that, I think it'd be awesome to have you back to see what those anti-patterns are for AI preparedness.
Sure, I'd love that. Thanks.
Thank you. Thanks for everyone for listening. We hope this was very educational for you, as it is for us. And we'll see you on the next episode. Thank you. Bye-bye.
Thank you.